on Monday. It is May the 12th. An absolutely lovely day out there. We've got some nice. I've got sun on 9/10 of my sky, and one little part over here, but to the south is and west is a little cloudy, but it's absolutely lovely tonight. So I have Randy, David, Natasha, David again, Jim Cox, CJ. Is there anybody else who has got any other bits and bobs that they would like to show or talk about tonight? Questions, comments?
We should do the announcements of the various things coming up between now and September.
Yeah, yeah.
So we
Okay,
can do
Randy,
that
can I give
together.
those to you?
Well, we'll do it together, Lauri.
We'll do it together. Okay, all right, then let's do that. All right, so we can maybe start off, and let's start off with an absolute bang. And Randy has got something that he would like to present to us.
Okay. And yeah, everything was so exciting last week that it didn't happen last week, which is just fine. Here we go, share. And let's start. You gonna do it? No, let's start this way. Got it. Okay. So as far as I am concerned, GAIA has been the most impressive, wonderful, interesting, inspiring space telescope going up there. It, like all things, it was designed, I think it was 30 years ago they started work on it, and then it was launched in 2013, and it's been mapping 2 billion stars and asteroids and quasars, and it's been doing the most amazing stuff, and it has finished its data taking mission. So I just want to go through this. Next year at some point, data release 4 will come out, and then I'll talk more about the science of it, but we'll have to give a bit of a background. So here it is, pre-deployment. The main thing you see is the optics are in this cylinder up here, and that is about the size of the, what's it called? The fairing, the part of the rocket that it sits in. And so in order to have this big heat shield, which will protect this part from the sun, it was all folded up. So it made one cylinder, and then once it got out of the Earth's atmosphere, then that great big disk went down. And this is what's inside there. It's mostly this very, very rigid, they call it an annulus, this tube that holds all of these. It's actually 10 mirrors. And you see the big one, these 2 big guys, they're huge. And they are, I don't know what the F ratio would be, but they are 35-meter focal length, which gets folded up into this thing that goes bang, 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 bang. And the light from these 2 mirrors ends up on what is the largest digital camera ever carried up to space. But it's not used like a normal camera. Really what it is, I don't know how many pixels it is from top to bottom, but thousands. And then that big cylinder spins around at a degree a second. Okay, it takes like 6 minutes for it to do 360 degrees. And every star will start here and move across. And as it's doing that, it is measuring the timing. The timing is very important. And so it has an atomic rubidium, I forget which element clock in there, and it's accurate to 10 nanoseconds. Okay, that's how long it takes for light to move, like 3 meters. Okay, and so each of the stars will go across and it will measure where it is in this vertical position and the timing in the horizontal position. And then for a little bit of value added, it then measures how bright it is in the blue and the red photo range, color ranges, so that you can get a quick picture of the color. And then for the stronger stars, there's a prism, and you can get a you can see the spectral lines, and you can get a radial velocity from the Doppler shift. Anyway, this is the infographic that came out recently. So over 12 years, 3 trillion observations. Just imagine that. 2 billion stars and other objects observed. Again, solar system, quasars, even galaxies. It just measures light. It doesn't know that it's a star or otherwise. Lots of pixels in the camera. It's spun around 15,000 times. Go back. It keeps its speed very, very, very accurately by spitting out bits of nitrogen. And that was the problem, is that eventually it ran out of that stuff. It was only supposed to last 5.5 years, and it lasted 12. So, it's not bad. 0.5 terabyte of data. That's not bad. And there's so far been 13,000 publications that make reference to GAIA. And it's really fun to go through the list. Every once in a while, I'll go take a look at papers there to help me choose what I'm going to talk to you about, because I love GAIA data. Anyway, this press release came out, I guess in early January. I'll just read this first bit. The GAIA spacecraft relies on a cold gas propellant to keep it spinning and scanning the sky. The amount of remaining cold gas decreases by about 12 grams per day and is reaching its end in early 2025. The GAIA science observations will therefore end on January 15, 2025, meaning that no more nominal science data will be acquired by GAIA after that date. Okay, so it stopped collecting data, but then they left enough fuel to fool around with things for another 3 months. And that's what I'm talking about today. The next paragraph is saying that data release 4 will be of the nominal mission, that 5.5 years. So that finished a long time ago, but they still haven't been able to gather all that. So we're working, when you look at GAIA data right now, you're looking at version 3. Version 4 will come out next year, and then the full data set will not come out until after the end of this decade. They have a lot of crank turning to do. And part of the thing is they're going to use the results of these 3 months, because it is so incredibly dependent on temperature. And so they're going to do things like spin it up and change its angle with respect to the sun to make a different temperature and things like that. They're going to do all sorts of things that they would never have done when they were taking good data. But now that it's time to fool around. Let's talk about this. After GAIA's science observations end on January 15, a period of technology tests will commence. These tests will allow us to study in more detail the behavior of some spacecraft and instrument components, with the potential of further improving the Gaia calibrations and aiding the design of future space missions. Yeah, so also just when they say that they're going to tell us where these stars are to within 10 micro arc seconds, that is equivalent to like a toonie on the moon. Okay? And just note that there is no telescope on Earth that can even see the lunar modules on the moon. The only instruments that have ever seen those instruments is the Lunar Reconnaissance Orbiter going around the moon. Nothing on Earth has ever seen something that way. But this machine is able to get angular positions to the resolution of a toonie on the moon. Just think of that. But because of these sorts of calibrations, it's incredible. After these tests, which will last several weeks, the Gaia spacecraft will leave its orbit around the Lagrange point L2 to be put in its final heliocentric orbit away from Earth's sphere of influence. Eventually, the Gaia spacecraft will be passivated on March 27. Okay, so I've been meaning to give this talk since then, but here it is now. So this is really lovely. The solar aspect angle, it's always been set at 45 degrees for the last 12 years because they want it always to have the same amount of insolation so that it always maintains exactly the same temperature. But during this period, they wibbled it around and spun it up and slowed it down. And so here's the schedule of it, because usually the thing was visible only at magnitude 21. And I don't know, Gary, what's the lowest magnitude you've ever seen with any of your fancy astrophotography methods?
Teeny weeny little stars, that's all I know.
Okay, anyway.
If Diane Bell was with us, she could tell you.
21 is really small, but they were saying it's going to be great for the amateur astronomers because it's going to go up to 15, which I think is still pretty dim, but there you go. And in particular, I've shown you that on March 2nd, you see how it's becoming brighter, and then it's bright on March 4, and then it would go back to 45 degrees and not be visible again. And some clever person, you can't see at the bottom, he was in Beijing, he took this movie. So I gotta get that movie going. How do I do that? There's a button down at the bottom. Okay, so Alex, you have to go to the chat and undo all the chats. Otherwise, I can't play this movie. Do you see where it says chat? Yeah, on the left, left, there. And then Chris, we do something at this point.
Well, actually, the bar that's in your way is the one that's on your computer. So is there anything you can...
Oh, it's on my computer.
Yeah.
Yeah, you see that? That's your Windows taskbar.
Oh, that's the problem.
So,
I got it. Okay, so do you see that little thing going across? That's Gaia. And whoop,
Oh.
that's it. That's the last time any human is going to see Gaia at magnitude 15. Do it again. There it's going and going and going and boop. I love that film.
So sad.
You're so nerdy.
Yes, Anna. Last time.
Although I appreciate it too.
Boom. Okay. That's what I wanted you to see. Come on. Next video. Okay. So then on the 12th, on April 12th, then you see this thing there, that's it flying around the Lagrange 2 point. So that is on the line between the sun and the Earth, and then a bit further along, there's this stable place for things like the JWST and Euclid, but also GAIA. And incidentally, in order to get these measurements done accurately enough, they had to know where GAIA was in that nest of orbits to something like 10 meters, because the amount of time it took for the time to get back to the Earth, there was some relativistic thing that you needed to know exactly its speed and its location to, like, within 10 meters. I don't know how many 100,000 kilometers away it is. But on April 4th, then they used the very end of its fuel to push it off into an orbit which is now going around the sun instead of around the Earth. Okay, and then what's cool is every 14 years, Earth will get kind of close to it. So it's going to have its own orbit, and the Earth has its orbit, but they will cross each other. The Earth will do an extra orbit, I guess, every 14 years. So somebody might see it again, but it's not going to be any, bright magnitude 15. Okay, so this was the press release back around somewhere around April 14th. GAIA spacecraft holds a deep emotional significance for those who worked on it. Thousands and thousands of people. As part of its decommissioning, the names of about 1,500 team members, well, there you go, who contributed to its mission were used to overwrite some of the backup software stored in GAIA's onboard memory. Personal farewell messages were also written into the spacecraft's memory, ensuring that GAIA will forever carry a piece of its team with it as it drifts through space. Turns out it's very difficult to passivate a spaceship that has so many redundant features. It's set so that if there's a glitch, it's going to restart.
Yeah.
It's really, really robust. And so to make it die took a lot of work, but they did it. And they also did this. This is just an Excel spreadsheet that was of live data coming off it. And obviously they set it up so that when the numbers are below, I don't know, something like 0.5, it was a different color. And the engineer who did this decided to set it up so it actually did this little message for the people watching it. So this was the video of them saying goodbye to it, and they did this to the data set, which is very cute. And with that, we say goodbye, but there's still a lot of work and a lot of really interesting science that we're going to get for years and years and years.
Amazing.
So goodbye, Gaia.
Thanks, Randy. Does anybody have any questions?
I do in the room, it's Shauna.
Sure, go ahead, Shauna.
I'm curious, you said, Randy, that the data you had to have the location of GAIA to use the data. So does the data have the location?
Oh yeah, but
Oh.
if you take a look at the cooked up data sheet, and you can do this. This is open science for everybody. You can say, I would like to take this 2 billion row spreadsheet and please tell me all of the 07 stars with a binary partner, which is a G type star, that is between 100 and 150 parsecs away. You know, you can do these searches and it gives you the location, the distance, the speed that it's moving. If it's one of the brighter stars, which still means like, you know, 100 million of them instead of 2 billion, then it also has the three-dimensional motion. So you know where it is in 3 dimensions, you know where it's going in 3 dimensions, and then is it a variable star? What type? Is it a binary star? What is its binary member? So there's this spreadsheet that you get. It doesn't give you all of the 12 years of data, the hundreds of times they have located each one of these things. It's that whole time series over the 12 years that gives you that information.
Neat.
It's
Yeah.
wild.
Yeah, sounds amazing. Like an atlas to the universe.
It is a 3-dimensional atlas.
Yeah,
Absolutely.
neat. Thank you.
And with that 2 billion, it's still only measuring like 1% of the stars of the Milky Way.
Randy, those of us that are using PixInsight now use GAIA data when we're doing plate solving.
Cool.
Yeah.
But again, you're using down to magnitude 15 or maybe 20. It's going down to magnitude 25, I think.
Yeah.
Randy, there'll be no coffee tonight. We
Aw.
don't have any mugs. I didn't get a message from Kathy until I was leaving and.
Oh, and she took all the
she
mugs
took
with
something.
her last time.
Yeah, so there's only one mug and, you know, if you want to fight over it.
No coffee
It's a good
today.
idea.
Sorry, Elaine.
Yeah, Randy, we download the full magnitude scale. Some people have big telescopes. Not me,
Oh.
but
Dave, how faint are the faint stars that you can see with a good long, like one of your major efforts in astrophotography, what magnitude are the dimmest stars that you can resolve?
well, it's in the 20s because
Wow.
can actually see stars in Andromeda, right? So they're
That's a good point. They must be down there. That's,
I imagine so.
you're absolutely right. Jim, do you know? Jim Hesser.
Sorry, I was paying attention to something else and missed the discussion, but the chances are, no, I don't know the answer.
What magnitude are stars in the that you can resolve in the Andromeda galaxy?
They're
Ish.
exceedingly faint. They're fainter than 21st, which is a number I heard coming up before. But I don't know. I'll guess 24th, but that could be dead wrong.
Okay, and that's about the limit of GAIA. So that's really interesting.
And I looked it up, Randy, with my 25-inch scope, you can see about 16 or 17.
With your eye or with
With your eye.
Right.
Just to put this in perspective, the first star distance by parallax was measured by Frederick Bessel in 1838. Then they couldn't measure many stars because it was so difficult until photographic methods occurred. In 100 years ago, they had measured the distance to 2,000 stars by that method. And by 1995, photographic methods have only measured 8,000 stars. So how many stars is it now? It just
Well, stars, it's about 1.8 billion.
1.8 billion. So we went from 8,000 to 1.8 billion. A significant enhancement. It's just an amazing achievement.
Well, my little ASCAR will resolve individual stars in Andromeda.
Wonderful.
Yeah.
That's so cool. Okay,
Right.
we're done.
Okay, thank you. Thank you very much, Randy. So we've got a couple of other people who would like to give a couple of other little things. Jim Cox, you said you had something for 4 or 5 minutes?
Yeah. We'll come up to the camera here so you can see it.
Yeah.
Oh. The little adapter. It goes from 1-inch eyepieces to 1.25-inch eyepieces. It's a complement of the plumbing wholesale shop. They're easily available for about $10. So anybody with an older telescope with a 1-inch eyepiece, you can, usually those eyepieces aren't all that high quality. And with this, you can use modern 1.25-inch eyepieces with it. What I did was the little screw you get that holds a glass globe on a lampshade. And I stuck one of those in the side of it here and threaded it. And needs to be painted black. Works very well. I already gave one to Sid. He was quite enthralled with it.
So what sort of telescope has a 1-inch eyepiece?
Oh, they're 0.962. The real old telescopes.
Okay.
The old Random telescope.
Oh, that's the one that you got the diagonal for,
Yeah.
that goes to one
Yeah.
quarter.
The old
So this-
Random eyepieces.
This drops right in there, and your 1.25-inch eyepiece there drops right in the top end.
Right.
I ended up with a 3-inch Mac with a 1-inch eyepiece on it, and this fits beautifully.
Well done.
Thank you, Jim.
Yeah.
Anybody have any questions for him? All these inventive people here. You know, I just curse and swear when things don't work, you know, so Reg.
I just wanted to mention about magnitudes. Some of you probably remember Michel Michaud. He was a very active member of our club, and he was a very keen measurer of double stars. And in particularly, he was monitoring double stars and Pleiades. And he was using a 14-inch Schmidt-Cassegrain on the VCO to do this. And his measurements went down as faint as magnitude 19 that he was using for his studies. So give you a bit of an idea there.
Mhm. Okay. I didn't, I regret to say, sorry, I didn't ask if there was anybody new online tonight. I think I recognize most names, but I just wondered if there was anybody, is there anybody at the center that is new?
We're all old.
We're all old, yeah. There we go.
Very
Okay,
good
I just
speech.
want to make sure. So thanks everybody for joining in tonight. Okay, let's do Natasha. You said you had a little bit of something you wanted to let
Yes.
us know about.
Thank you, Lauri. And yeah, that was really interesting about the GAIA. Randy, thanks for that. So this Friday is the International Day of Light. And it's interesting because I'm just going to share my screen. It followed a similar trajectory when we had the International Astronomy Day. So the International Year of Light took place in 2015. And there was such a good response to it that they created these annual days. So this Friday is the annual Day of Light. And so there's activities all over the world. I'm just going to play this very short video. It's 59 seconds.
Does it have audio, Natasha?
It does, but I'm not hooked up for it.
Not hooked up for it. It's okay.
Okay.
The International Astronomical Union is a big participant in this project. They were one of the original sponsors. So that's that. And so I think I've got one more thing to share here about this. Oh, yeah. Can you see this cosmic light image?
Yes.
Okay. So that was the logo for the original Year of Light back in 2015. And I was involved with it with Kimberly from Chandra X-ray Observatory. She put together an incredible project that, and part of that collaborated with her. So
Natasha, we're still just seeing the beginning of your video.
oh, okay. I'm going to stop sharing that then and then share
Okay,
something
sorry.
else. That's okay. It's good. Okay.
Yeah, there we go.
Yeah, so that was the original logo in 2015. And as I say, I'm sharing this with you because there's certain parallels to when we had the International Year of Astronomy in 2019, and then subsequently, you know, the International Days of Astronomy. And there are opportunities here to collaborate perhaps in the future. As I say, the International Astronomical Union was a very big supporter of the project. So maybe it's something to think about for next year. And they approach it as an outreach opportunity, and because it's pretty wide in its scope. And then that website that I put together that I showed you earlier on the solar wind, that came out of this project. And so, yeah, just wanted to let you know it's coming up. It's this Friday. And I'll try and find the IAU link to it and put it in the chat. Thank you.
Thank you.
Thank you. It looks like we may want to look into that a little bit more maybe next year. We didn't get on it. It's in the middle of a whole bunch of other things, but it might be something that we might want to look at to see what else we could pull into some of our programming.
Yes, or even just piggybacking on a particular project.
Yeah, yeah, and getting in there. Okay, thank you, Natasha. David, there's a couple of things that you have on your list.
Yes, can you hear me now?
Yes.
Okay, that's great. I just wanted to mention one little observing thing that I did. It must have been about a few days ago before I got my cold. I was up at I think at 4:30 in the morning, hoping that I would see a number of planets, but I only saw one. I saw Venus, and I didn't think to grab my scope because it was really easy to grab my camera. So I actually don't have it readily available here, but when I photographed it, I said, "Oh, there's Venus like in the blue sky," and I decided to sort of blow it up. And when I looked at it, I thought, "Oh, that's kind of odd." And then I realized it's actually not fully lit right now. And in fact, I looked it up on Sky Safari, and even though on the photograph it was kind of overexposed, so it looked like it was like half, but it was more like I think 33 or 35% or something like that. So if anybody is up early in the morning and look at Venus, have a look with a telescope or high-powered binoculars, and you will see a crescent. So crescent Venus. Okay, so now I'm going to share. I guess you want episode 1, which is the second of the video series, right? I'm assuming that's what you want.
Let's introduce this. This was an email. This was an email from
Nick
Versteeg, who has been working with Chris Gaynor and other people on the movie of the book. Oops. Oh dear. I just did the
I'll try to spotlight you.
So, are we on again yet?
Yeah.
Okay, can you hear me? Can you hear me?
Yes.
Okay, good. So, yeah, this is actually Reg's copy. He lent it to me. And, it's a great book. And, it is now being made into a movie by Nick Versteeg. Okay, so now he sent us 3 trailers because sometime in June, Czech TV is going to put it on as a, as a show on Czech TV. And we will certainly advertise that in the email.
And the program is the movie is being I guess launched March 4th and 5th, I believe. Oh, I hope I've got the right dates. And it's going to be showing up at the center, and Nick has got all of his staff and his crew kind of seeing it at one point, and then the Friends of the DAO are also putting on a time, but we're only allowed like a certain number, like 60 people or so inside, and we wanted to invite like everybody with the RASC, and there simply wasn't enough room. So what we've decided to do is Nick has said that he'd be happy to have a special showing, and I was thinking actually it might be really nice to have it at the university for one of our programs in the fall, like either the September or October meeting, that we could show it at the university and be able to invite like lots of people who might want to come and see it on the big screens would be wonderful. So
fantastic, and get him to answer questions at the end.
Yeah, it would be really nice to be able to have them come for that. So that's what we'll do. So, but I think yes, Czech TV is also going to be showing it as well. But we have a little bit of an in on knowing that. Okay, I'm going to David. I'm going to let you highlight, or you can let you put your screen on here.
For the next 5 weeks, we're going to show you the making of Northern Star, the documentary on the observatory on Saanich Mountain. It all started with this book, Northern Star by Peter Broughton. I met with Peter Broughton in Toronto, and he gave me a lot of great background information. We visited the University of Toronto, we looked to the archives, and we also found the boy's own annual that played such a big role in Plaskett's early life. And we worked together with science writer Chris Gaynor to write the story of the documentary. We're gonna get the rights for the NFB film. I watched it, and that's a perfect explanation actually of what they do. We got a proposal and a rough script, and together with our great host Bob McDonald, we created a trailer.
105 years ago, Canadian John Stanley Plaskett had a vision to reach fainter stars, and a larger telescope was needed. And if Canada could build one, it would put Canada in high standing in the world of science.
That was the easy part. Now we just have to find a broadcaster.
So that was episode 2.
Did the other one come on, David?
Well, do you want to see the third one? I thought we were going to show them every week, but I can show you the last one.
No, go ahead.
We've seen that one already.
Go ahead.
No, we saw the first one. This is an episode 2. Sorry, 1. And I have one more. But
yeah, let's do it today.
Let's do it.
Do it today? Okay.
Yeah.
All right. Okay, here we go.
Okay, in this episode, we're going to talk a little bit about pitching, what is always a challenge. Years ago, when we're still doing a lot of stuff for television, I would travel to New York, Toronto, pitch ideas, and we would come always back with a new project. Well, that time is gone. It takes a long time to pitch an idea and to especially get the funding for idea. So in this episode, we're really going to talk about pitching the idea and getting it done. With the help of the friends of the Dominion Astrophysical Observatory and CBC Quirks and Quarks host Bob McDonald, we created a trailer. And this we took to a variety of broadcasters.
Using this magnificent telescope, in 1922, Plaskett became famous for discovering the most massive star known. It's a binary system, 2 stars going around each other, that today is still known as Plaskett star.
We always knew that Canadian broadcasters asked for Canadian stories. Well, this cannot be more Canadian.
Well, Northern Star is a Canadian story, and most people don't realize how much Canada's done in astronomy and space science. We are in the top 5 in the world for astronomical publications, what our scientists put out there to the world. Most Canadians don't know that, but we're pioneers in it. So this is the story of one amazing person, John Plaskett, who built this, what was the world's largest telescope, right here in Canada. Go figure. So if you want to find out what Canada can do, watch this documentary.
We tried a variety of Canadian broadcasters, and they all came back to us and they said, great story, let us know when you have it done, and we have a look at it. Well, a production like this costs money. And then there was CHEK, our own Vancouver Island employee-owned station that gave us a broadcast license. With that broadcast license, we went to the Canada Media Fund, who gave us some extra funding. With that, we finally could start our production. This entire process took 2 years and an enormous amount of paperwork, but we finally could start producing the production. Next week, how to tell the story of John Stanley Plaskett.
I noticed that there was a word, but the Plaskett was spelled wrong in that right about in the middle sometimes. So we're going to have to we'll talk to Nick and say, that needs to be fixed. So for sure. Okay. It's I think it's going to be really a very neat program to be able to see and to have for Canada. So that's just great. Thank you, David, and thank you, Randy. And let me see. CJ, did you want to talk to us about your new toy?
Well, it's not really my new toy. It's a toy that came back to me because I forced somebody to buy it. So I don't know if you want to see the story.
I'm gonna spotlight you here. Just a minute.
Okay, yeah. So basically, it's okay. I'm trying to make so everybody see it. So that's an astro compass. That's a device that is still used today in aviation, in airplanes up north, because Transport Canada requires to have 2 means, self-sufficient means to know where you go. So basically you have a gyroscope and a compass, but as you go higher in latitude, the compass is not usable anymore because of the magnetic field going into the Earth, then it gets wobbly. And the gyroscopes actually precess 15 degrees per hour because the Earth is spinning. So that means that after a while, you don't really know which direction you go. So we have that on board. And it's actually...
CJ,
yeah?
You actually are a Arctic pilot, right?
Yeah.
Like, what sort of things were you doing up there?
Oh my goodness, yeah, so just as background as myself, yeah, I immigrated from Switzerland with a one-way ticket to Yellowknife to become a bush pilot.
No kidding.
Yeah, in 98, and I became a twin otter pilot for First Air. And out of Yellowknife, we would support the communities, but we would do tourism, mining industry, the most across Northwest Territories and Nunavut. Then I went flying in North Africa for a Swiss company. We were using the Astro Compass. Then I went back for flying from Canberra Care, based out of Resolute Bay. And I've flown Baffin Island, Ellesmere Island, Greenland, Antarctica, and the Maldives.
Wow.
For all time. So we've flown for the NASA on the Broughton Island, on the Devon crater for their Mars exploration site in 2004. Yeah, we've flown for the Polar Shelf program, Canadian Polar Shelf Study, geology, for a countless number of scientists. And in Antarctica was mainly for science. The Concordia station with observatory over there and South Pole, and so yeah. Anyway, back to the myself. So the Astro Compass is actually like a sextant, but for airplane. So if you take these, it's reversed. So the pier is actually fixed on the plane, and you can actually remove the Astro Compass. And the Astro Compass tells you where you go. Then here, if I turn it around so everybody can see, you set the latitude at which you are, and that represents the ecliptic of the ecliptic. And of course, if you're at the North Pole, then it's
the equator.
The equator, that would be North Pole because the North Star would be vertical. Then the equator would be the other way. So that represents the ecliptic. Then here you have the elevation of the body you want to use to set up your compass. So then during the day, you use the sun, and this little index over there casts a shadow in the back. And you reverse it at night to use this little lens over here to look through the little groove to point at the stars. So you take your ephemerides, like you have tables. So if you know where you are and you take the date and the time, then you say, well, Venus or whatever planet Aldebaran is at that local hour angle. So you set up the local hour angle over there. Okay. Oops. So you set the local hour angle of the stars. Then when you want to know, then you align, you put your Astro Compass back into the fitting, then you align the Astro Compass so the index aligns. So during the day, it casts a shadow. Then when you have the shadow aligned, then you read over there, let me see, yeah, here. You read here the heading, the true heading at which you go. That allows you to know exactly the true heading of your plane. Then you set up your gyro, then you can keep flying. So that's a neat use of astronomical knowledge on every day, not every day, because now we have GPS. But yeah, I've practiced that, and it's quite accurate. To know the heading, you're precise, maybe 1, 2 degrees, 2, 3 degrees, and it's sufficient to get around. Yeah, so that's it.
Wow.
How old is it? How old is it, CJ?
This model is quite recent. Most of them they've been built for Second World War. I think that's an Enkin Mark II. I think it's a Mark II, and most of them they've been built in the 40s. And then with the navigation, the modern, most of the planes had it before the radio communication, radio beacons, NDB, VOR that we have now, besides GPS. They would use that even during the war. Every airplane during the war had that. And in the 50s, they came up with the radio beacons. Then it would be a way to find your direction with radio beacon. But Transport Canada, they require us to have non-broadcast, self-sufficient means, at least 2 systems. And gyro compass and magnetic compass are the 2. But since the compass don't work, they require that on board. Still.
Shall I tell the history?
If you want, yeah.
This is Shauna. So what happened was Peter sold it at our sale in the fall. He had used it, right? He was a pilot, is that right?
Yeah, he was a pilot.
Yes, so Peter, you know Peter, everyone? Are you there, Peter? Maybe he's there. He was a pilot, he sold it to me for my nephew who's a pilot for Air Canada. But my nephew said he lives in a bachelor in Vancouver. and had no room. He said he'd store it at my brother's house, so I told CJ it sounded like a waste. So CJ had encouraged me to buy it, and I knew he knew it, so it's come back to him.
Well, thank you for the whole set of stories, and I do believe Peter is online tonight as well. So
Oh, good.
I remember seeing it when Peter showed it to us earlier, a few years ago, 2 or 3 years ago, I think. Okay. Anything else? Any questions for CJ or Shauna? Okay.
First, CJ, it sounds like with your experiences both in the far north and the Antarctic, perhaps you should write a book.
Yeah, I should. I could. Yeah, I have quite a few stories. Yeah, for sure. Maybe I will.
Sure, people would find it interesting, especially these days with the far north being, everyone's got their light bulbs focused on that these days, and of course Antarctica too. So yeah, that'd be great.
Well, I could do a little presentation on one project that I've followed a little bit at Concordia Station, which is the high plateau of the Antarctica, where in 2004 they were starting to measure the seeing of the sky at night for installing infrared telescope, because at night in the winter in Antarctica it's minus 40, 50 and 60 and below, and it's dark 24 hours a day. And they were measuring the seeing, so they had to build up some contraption to have a 16-inch telescope, Cassegrain, to measure the seeing at that location. And I have my own personal pictures of that, and I could do a presentation if you want.
That'd be great.
Okay.
Yeah.
Great.
Super.
I have a question, Lee. So you kept saying Transport Canada requires two measures.
Yes,
Do
self-sufficient.
they
Yeah.
still require that even with GPS?
Yeah.
Oh.
Yeah. As far as I know, in aviation, redundancy is key. So you have to be able to continue navigating even if you have a total electrical failure. So that's why the compass is the last. Even now on an Airbus 320, they have a little box and they open it and there's a little magnetic compass in it. So they still rely on magnetic compass today. Yeah.
Wow.
That's reassuring.
They don't rely only on that. They still have it on board. They have like 5 or 6 layer of redundancy for navigating now.
They have to.
Hey, thank you very much. I think maybe we could turn. I had asked Jim Hesser to just talk a little bit about a program that we went to on Sunday. If Jim, if you wouldn't mind giving us a little bit of some background on that.
You don't want to hear about the program that I went to on Sunday, but Saturday evening.
Oh, Saturday. Sorry. Yes,
you
Saturday.
And,
yes.
And Chris and Audrey and perhaps many others online this evening were at the Church of St. John the Divine, which was the Plaskett family's church, for a performance, a quite creative performance by the Victoria Baroque group, and the title of which was Time and Space, with the projections designed by Ben Dorman of the Center of the Universe at the Dominion Astrophysical Observatory. So it was a program that combined music from the Baroque period to contemporary pieces, broken into sections with introductions via poetry that the musicians read. The whole program was conceived by Christina Hutton, who plays the forte piano and the organ for Victoria Baroque, and Christina provided some condensed notes about her vision for this program that would combine poetry music spanning centuries, and beautiful, beautiful images that were assembled by Ben Dorman. And he acknowledged all the people in the RASC and the FDAO whose images he used, as well as, of course, images from space telescopes like Hubble and JWST. And I think all of us found the concept of the program to be really interesting, very creative. The program ran without interruption. That is, it turned out the timing, however Ben did it, the timing for the pictures that he had selected to run with each piece seemed to work so smoothly that he came out from behind the screen and just sat in the audience and enjoyed the program. So it was an evening of extremely beautiful music, of many different epochs in musical history, and beautiful, beautiful images, many of which were taken by people who were on the video or at the Fairfield Center this evening. So very, very special evening, I thought. I enjoyed it tremendously.
Thank you, Jim. And thank you to Dave Payne, Ken McGill, who are some of the other people on that list, Jim? John McDonald.
Yes, let's see. I think somewhere here I've got the list of names.
I think it's at the end.
Yes. Dan Posey, John McDonald, Brock Johnston, David Payne, Ken McGill, and Ron Fisher from the local astrophotography. So as distinct from the 2018 Herschel concerts done at the cathedral, where all the astrophotography was local, this program did involve many space images as well. And those of you who had the opportunity to attend either of the two concerts of the Herschel music knew or probably had the experience that most lay members of the audience thought the pictures taken by local astrophotographers were by Hubble. That's the quality to which people here achieve in their work. But so this time there really were some images from space telescopes involved, but still lots and lots of pictures that even I recognized from local astrophotographers. It was a very, very special evening. I guess it ran about, I'm guessing 80 minutes, 70 to 80 minutes. I didn't actually time it, but as I said, it was without intermission, and they started at 8 o'clock when the hall was still rather well lit by daylight. So the initial images got pretty badly washed out by the ambient light, but by the end of the concert, it was quite dark in the hall, and the pictures really were spectacular. So it was a great evening from our perspective.
Thanks, Jim. Yeah, it was fun. Randy, we have some other things.
I just want to add about astrophotography and concerts. Catherine Whitney is with her choir, the Newcomb Singers, is in December, is going to be featuring the Sunrise Mass of Ola J-Lo. J-Lo? Okay, and she wants us to collaborate with that, and I mean, I said we would love to, and that's as far as we've gone so far, but there will be another, there'll be work on this for a performance in December.
Excellent.
At one point, I was sitting beside a lady in a at one point the pictures were all of the sun. The images were all of the sun, and one of the pictures was that gorgeous photograph that John McDonald took in 2017 of the eclipse when we were down in Oregon. And it was like one of the most spectacular shots that I've seen. And she looked around, and then she brought up her camera, and she was taking pictures of John's picture on the screen as surreptitiously as she possibly could. I don't think nobody said anything about like you weren't allowed to take the pictures or anything like that. But she said that was the one that just caught her eye. Absolutely, was this beautiful picture of the eclipse. So it was lovely. Randy, we were just going to give some announcements of what's happening between now and whenever.
So tomorrow is council meeting, and there's an email. It was the email that was sent April 29 to Sky News. So if you want to join, Wednesday. Is Kirsten here to talk?
No, she's away.
Okay. So anyway, Bryn Lonsborough is going to talk galaxy clusters and galaxy formation in the early universe in room A104 of the Bob Wright Center. And then coffee, cookies, and conversation. What does that mean, Alex? What are you making for tomorrow? Or Wednesday?
You will see.
You gotta come. We don't know yet.
Apple pie.
Fantastic.
This is the last speaker at UVic until September. And so, especially if you want to go to the library, this is the time to do it. There is no Astro Cafe next week because of Victoria Day, and then the following, the 26th, will be the last one of the season, and we get a break, and we get to load up the computer with, update the computer and things like that, and we'll come back together September, I suppose, 8. So then let's talk about the star parties at the DAO, Lauri, and then we'll talk about the Island Star Party and Sanish Fair. So
our star parties are now twice a month. We had our first one, of course, for International Astronomy Day, and again, thanks to everybody who came out and helped with that. And our next one is on the 17th of May. And then another one on, I believe it's the 31st. I haven't got my calendar sitting right here in front of me, but I think it's the 31st of May. And then we will again be in June. So it will be June the 14th and June the 28th. And then after that, then there'll be every week for all of July and August. And then in September again, we will have we'll have a couple of other star parties, but we also have the Vox Humana that comes in on that second Saturday night and that kind of thing. So we're always looking for people to come up and help with our welcome table. It's Clint and Melissa Tepper are the people who look after that. And we'd love to have some people come up and do that. You're sitting and just chatting away to people. And any of you who have done that before, I see some people online here that have been on that welcome table. And it's so nice to see people and not just have the table basically unmanned, if I can use that term. It's really nice to have people chatting away and telling about what's happening at the RASC, because we really do get a lot of the public comes up that doesn't really know very much about what's happening in astronomy. So this is one way that we can also talk about our programs as well. So if you are interested in just one night just coming up and helping out, and in fact, actually, it's really fun when there's two people at the table and you have a chance to chat, and then one person gets to see one of the presentations and another person gets to see the other one, and you can share that off. So grab a friend and come on up and be part of that. And we always need people up on the deck, out on the parking lot, and we're also going to be opening up the 16 inches being fixed. Brock is doing a lot of work on that right now, and we'll need some more. We'd love to have some more people be part of that. And the other thing, and maybe Reg, you can help me with this, is we've got fabulous 20-inch Dob sitting right in the corner of the center of the universe that wasn't really out for very much. But if anybody's interested in learning how to use that and to bring that out onto the deck and let people see through a 20-inch Dob, that would be just fantastic. Reg, I don't know whether you've got any other information about that or what needs to be done, what kind of training we could have for people to do that. Can I turn it over to you for that?
It's basically pretty easy to use. It's like any dog, but this dog, when you roll it out there, you get a huge lineup behind it because bigger the better. So flash it up, point it at an object, and especially during the time when the stars don't get so dark, when the skies don't get so dark, it's a good tool to use. So
yeah. Oh, thank you. Well, I just if you're interested in learning how to use that, then that would be just great. I think that's just about all for now. We've got a full lineup of presenters for the summer. I think most of them are all done. And I think David, do you want to talk a little bit about the next one coming up on the 17th? Because that's not the 17th. Sorry, it's the 17th or the 21st or 31st that is the clinic.
Oh, excuse me. You're thinking of the 31st, right?
The 31st. Okay, sure.
Yeah. So it's the day where you bring all your broken telescopes. Well, not necessarily broken. Telescopes that need to be maintained. So we're going to have an evening of kind of general talks. I mean, they're mainly for people that are just starting. So you'll get an idea of what different types of telescopes there are. And then you get to go out into the parking lot and hopefully experience probably each type and their owners who will tell you about their stories about them. Also, I think there are a couple of maintenance issues that people have already cited that they will be bringing telescopes, typically for things like either cleaning or collimation. So I believe we have the people that we need for the speakers that are the short talks, but we certainly need people that are able to assist people by maybe reviewing their telescope. Maybe it doesn't need anything at all, right? And they just need to know how to use it. So anybody who has a desire to do that, join our team. So we have some main kind of mechanics, but we could certainly use everybody's help.
Thanks, David. Back to you, Randy.
Okay, so the big event of the summer for our center is the Vancouver Island Star Party. So remember, I guess it's 2 years ago, we have been offered the opportunity to have the Island Star Party. The Cowichan Starfinders have been running it for 3 decades, and they are having a hard time having the volunteer base. And so we've taken over running this event, and it's always on the weekend of the newish moon in August. And so this year it is Friday, August 22nd, and then we'll have 2 evenings of speakers and events, and then clean up on the 24th. So it says August 22 to 24, but it's finished in the morning of the 24th. Come with your tent, or just drive in and drive home in the evening. It's at St. Stephen's Church on help me, what road is that? Is that Mount Newton?
Mount Newton Crossroad.
Good dark sky, and it's a good time. We had a couple of hundred people at the peak last year, and which is about capacity. We always have good speakers, and we have some daytime activities. So we'll need some volunteers, but mostly what we need is participation. So plan around that. Don't go out of the town at that time. Come to our party. Let's get together. And then 1 week later, I'm going to pass this back to Lauri.
Yep. So the following weekend is the Saanich Fair. And so this will be on the Saturday of the 30th of August, and then the Sunday the 31st, and Monday September the 1st. Again, if you're not familiar with it, we have a whole section that we take over. We put our solar telescopes out. We kind of share the space with the friends of the DAO. We put out tents, all kinds of information, chat away to, as many as, 3,000-4,000 people on the weekend. If you thought that the IAD was busy, you have no idea compared to the Saanich Fair. And we have two slots, so from like 10 to about 10 in the morning to about 1 in the afternoon, and then again from 1 until 4. And we have groups of people that will be manning tables or are doing the solar telescope viewing, chatting to people. And when you sign up for this and you do your 3-hour section, you get a free wristband that gets you in for the entire rest of that day, so that you can come to the fair for free, as long as you do a little bit of some work in the middle there with our group. So that's always really a bonus for that.
And we're hoping for like 20 people.
Yeah, we need like 20 to 24 people, like in total over the time. It's just great. The more the merrier, to be perfectly honest. Because then you can be talking to different people in the back where the telescopes are, or the side. You can be doing in the front, that kind of thing. And I think we already have got a telescope that we are considering having as the one that will be the giveaway telescope for us. We've got it sitting. We need a little bit of some work at just making sure it's in good shape, and we'll be able to give that telescope away as well. I think I've already signed all the papers, and I've got all the insurance, and everything is all ready. So we're signed up and ready to go. So now we just need people. So you are definitely invited to come and help us out for that. We need lots of people to help with that. So thanks.
And that is by far our biggest outreach event of the year, and we get more members, which gives us more resources, which gives us more ability to put on our program.
Mm-hmm. Mm-hmm. That's great. Thank you. And then I think that's maybe it. I think maybe the only other thing that we might want to, we'll take a little bit of a breather, but I think we will be doing the second part of NOVA in the fall. Haven't quite got the dates nailed down yet. We have to make sure that we can get the times because we have to go in between things like cruise tours and stuff that are up at the center, but we'll see what we can do. It probably will be 5 or 6 weeks to finish off the rest of the course. And as far as I'm concerned, you don't need to have taken the first part in order to be part of the second part. It's a little bit of a different thing. You can come up and do that second part. So that will be great. We'll do that in the fall, and then we'll be back at the university and back at Astro Cafe and getting things all back in again. But I'm just trying to get to the end of this week, let alone trying to think about what's happening in September and October, but that's okay. So and on your behalf, on the RASC behalf, I made sure that I gave a gift to both Kim Goff and to Jennifer Vanderzee at the museum for all of their help that they gave to the RASC for IAD. I thought they deserved a nice floral gift from the center, so I did that. All right. Is there anything else that anybody has got that they'd like to chat about?
Reg is here.
Reg.
Yes, just before we leave, another bit of information about Gaia. Apparently the last official star that they measured before they turned off their scientific component. I know that it sounds like they had play days afterwards, but was the star 61 Cygni, and so it was the last star to crawl across the CCD panes there, and that was the first star that Frederick Bessel measured in 1838. So they
good for you.
Kind of a poetic closure to that. So there you go.
I totally missed that fact. I would have studied. Where did you see that?
Boy, keep my eyes open.
I love that.
I've got a couple of questions. First of all, David, was that Corona T Borealis going to go off or not?
Well, the next projected time is in November. I always check on AAVSO, and it doesn't seem like it's doing too much. But the next prediction, and I don't know how the prediction arises, but I think it's like November 26th or 27th of this year.
Okay. Are we expecting any comets or any? Like, is there anything that's down? I haven't done my homework to know that.
There's always comets. There was that comet we were chasing for a little while, but I think it disintegrated actually. So that's bad news.
And did the rocket come down to Earth? The one that was
yeah. I saw a little bit about that. It landed in water. That's all I know.
Oh, okay.
Maybe somebody else knows
Miles, do you
more
know?
about it.
The Indian Ocean.
Landed in the Indian Ocean.
The Indian Ocean. Okay.
And they don't think they can retrieve it.
Yeah.
No. Okay.
I mean, that was
All
the prediction anyways, because there's a majority of the surface of the Earth is water.
Yes,
So.
it's water. Okay. All right. Wait, anybody else have last chance?
Oh, I did want to say something.
Okay.
Speaking of opportunities to observe, I mean, of course,
Yes.
there's the newly fitted VCO, of course. We're going to try to have some maybe event-based things up at the VCO possibly this summer. And we'll continue to have the pop-ups out at Kettle Point, just so you know.
All right. Well, I think if that's
and the Henrietta Leavitt Memorial Horizon Watch. When is that going to be, Reg?
That is on July 4th. July 4th is a birthday of Henrietta. And that will
tell
be
the people about that.
Well, that is held at Cattle Point, and we assemble our telescopes not where people normally have it. Is kind of between the two boat launches. There's a really ideal place where you can go and look at Lopez Island and see one of the largest, one of the largest fireworks shows in Washington State. And the neat thing about it is after the show ends, the lights turn off, the muffled booms of the fireworks continue on for about 1 minute and 20 seconds. So you don't want to miss it. And quite often there's Viva Puffs there as well. So
I'm going.
Well, I know that Nathan has also always has brought cookies before too. So yes. There have been fireworks cookies. Oh, there we go. All right. Thank you everybody for joining us. And we will come together again in 2 weeks' time. And I'm not sure who is hosting that, Randy. Do you remember? Oh, Randy's hosting. Okay.
I know.
All right.
I'll do it.
Oh, thank you, Randy. All right. And if anybody's got anything that they would like to present, you can just kind of give Randy a little bit of a call. So tomorrow, if anybody's interested in just signing on to our council meeting, we're actually very nice to each other when we actually get together as a council. So there's not too many fireworks there. So we'll get some things done though. So we'll see you again in 2 weeks. Thanks everybody for joining in tonight. Thanks to all the presenters, to Randy and CJ, Natasha, everybody, and we'll see you again soon. Bye for now.
Thanks.